Okay, so when we left off in class, we were looking at graphing some different kinds of functions, and these kinds of functions, it's not like graphing a line where you can just grab a couple of points and, draw the line. You have to think about what the function is doing as x goes from negative infinity to infinity. As you go from left to right across the graph, what is this function doing? Okay, so the first thing you have to do is look at the limitations on this function. And we talked about the two things that you really have to pay attention to and look for. And that is, you have to make sure that if there are any square roots in your function, that whatever is in that square root has to be positive or zero. And if you have a rational expression in your function, the denominator cannot be zero. So before you even try to start graphing this function, you need to deal with those two things. So since the stuff inside the square root has to be 0 or greater, first thing we're going to say is that x has to be greater than or equal to 0. And what that means is that you're only going to be dealing with the part of the xy plane that is on the right side of the y-axis, because everything else on the left side, okay, so we're going to be dealing with this side of the y-axis. Everything on this side has a negative value for x, and that's not allowed with this function. So we know before we even start that this graph, whatever it looks like, is always going to stay to the right of the y-axis, even though it can also touch it. It could be, x could be 0. In that case, it's going to touch the y-axis. But everything else is going to be to the right. And then we look at the denominator and we say x minus 2 cannot be 0. So therefore, x cannot be 2. All right? So what that tells me is that there is a line that the graph will never touch. And that is the line x equals 2. Okay, and the line x equals 2 is a vertical line that goes through 2 on the x-axis. No points on this line can be on this graph because every point on that line has an x value of 2, and this graph, this function, cannot have an x value of 2. You cannot even put 2 into that function. All right, so now we have to figure out what's going on the left side of that line and the right side of that line. All right, so we'll start on the left side of the line. We know that that's this little alleyway of graph is all we have to deal with here because it can't cross the y-axis either. So the first part of this function that we're going to look at is the part where x goes from 0 to really close to 2. It can never get to 2, but it can get as close as we want it to. So we can plug in a couple of values for x. So if we make a little chart here for x and f of x, and remember f of x can also be called y, it is the vertical axis. If we put in 0 for x, we get 0 over 0 minus 2, which is 0. So the point 0, 0 is on this graph. If we put in 1 for x, 1 over 1 minus 2 makes negative 1. So 1, negative 1 is on this graph. We can't put in 2, but we could put something very, very close to 2. It's a good idea to put something really, really close to 2 so that we can see what this graph does as x gets closer and closer to 2. So if we put in something like 1.9999 for x, and you punch that into your calculator, 1.99999, or 4 nines, into this function, we're going to say 1.9999, and we're going to take the square root of that. So square root, and then we're going to divide that by 1.9999 minus 2. And I'm going to close the parentheses and see what that equals. Well, you can see that it is a really, really big negative number. And so on our graph, when we get really close to 2 on the left side, we're going to be at some huge number way down, way down there. So what is happening to the graph on the left side of that line is that it is shooting down as it gets closer and closer to the number 2. And it just gets closer and closer and closer and bigger and bigger and bigger in absolute value in the negative, in the 4th quadrant. So I didn't even put down what that was, but it was a big number. So big, no, negative number is what we got. Okay, so that is what's happening on the left side of the line x equals 2. And I think I said this in class, but this line x equals 2 is called an asymptote. And what an asymptote is just exactly what it is. It's a line that a graph or a function can get very close to and approach, but it will never get there. It can never touch it. All right, now we need to see what's happening to this function on the right side of that line x equals 2. So we could pick some values for x that would be easy. So we might pick x equals 4. So if x is 4, then we could put that in. We'd have the square root of 4 over 4 minus 2, which is 2 over 2, which is 1. So 4, 1 is on this graph. 1, 2, 3, 4, 1. So there's a point. If we put in 9 for x, we would have the square root of 9 over 9 minus 2, which would be 3 over 7. Okay, so if I put in 9 for x, I get 3/7. So when I come up here to 9, 5, 6, 7, 8, 9, I am at 3/7. So somewhere around there. All right. Let's see now what is happening. And remember, I'm going to be approaching that x-axis, but I'm never going to be able to cross the x-axis because if x is greater than 2, which in this part of our graph it is, it's on the right side of that line x equals 2, this can never be negative because the numerator is a square root, which will never become negative, and the denominator, x is bigger than 2, and that'll never be negative. So we know that on this side of the graph, we're never going to cross that x-axis. We're never going to go into negative territory, and our function, f of x, is never going to take on that value. So we know that as we go further and further to the right, this function is just going to get tinier and tinier. It's 3/7 when x is 9. If you put in 100, for example, for x, you'd have the square root of 100 over 100 minus 2, and that's going to be 10 over 98. Okay, so that's even smaller. So we're getting closer and closer to the x-axis as we go that way. Well, what's happening as we go from 2 to 4, which we already have a dot for 4. Well, let's see what happens as you get closer and closer and closer to the number 2 for your x from the right side. So say you have x equals 2.00001. All right, we'll try plugging that in. So we'll get our calculator back up here, and we will, where's the thing? Okay, so we'll go ahead and say 2.00001, and we'll take the square root, and then we're going to divide, I'm going to make some parentheses, by 2.00001 minus 2. I'm just plugging that value into the function. And what am I going to get? I'm going to get a very big positive number. So what's happening as you get closer and closer to 2 here is that this function is going to get closer and closer to 2, and it's going to shoot way up as it gets closer and closer to 2. So this is this function, f of x equals the square root of x over x minus 2. This is what the function looks like. It is two curves that approach this line, x equals 2. And in order to graph this, you have to know, it's not like you can just, it's not the same as the kinds of graphs you've done before where you just know some information and then you smash it down on the graph. This takes some thinking about what the function is doing. You have to think about how is it acting, what are the limitations on x, what can x not be, what quadrants am I dealing with, etc. So this is something where you have to think it through and figure out what the function is going to look like. Okay, so now we're going to look at graphing some absolute value and reciprocal functions. So first of all, the absolute value of a number is the distance of that number from 0. So it's always a positive value. Distance is always positive. And that's the distance from 0. Less than absolute value inequality will be a set of numbers that are gathered, well, they're not really gathered around 0. They can be, but what they are, it's a conjunction. So it's a situation where x is this and that. So you have a little group of numbers that are together, and they're not always gathered around 0. I shouldn't have put that, so just kind of scratch that out. But it's a conjunction. I'll show you what I mean by that. All right, so if I want to graph on the real number line, the absolute value of x minus 2 is less than 0. First of all, I isolate the absolute value, get it all by itself. So absolute value of x is less than 2. And so what does that mean? Well, that means if the absolute value of x is less than 2, it means that x never gets any further away from 0 than 2 spaces. So that means if the absolute value of x is less than 2, then you're talking about only the numbers in this area right here, because it can't ever get any further away from 0 than 2 spaces. That's what absolute value of x less than 2 means. It means the distance from 0 of x is always less than 2, so it never goes any further away than that. Therefore, another way you can think about that is to say x is greater than negative 2 and x is less than 2. And it sounds weird to say that x is greater than something, but if you think about negative numbers, kind of the bigger you get with a negative number, really we say the smaller you're getting, because the bigger the absolute value of a negative number, it's less and less and less, we say, because it goes to the left. But in order to get closer to 0 on the left side of the number line, you've got to become greater. So getting close to 0 depends on which side of the number line you're on. If you're on the left side of it, where all the negative numbers are, you have to have a greater value to get close to 0. When you're in the right side of 0, you've got to get less to get closer to 0. So it's a little bit against what you usually think about when you think about getting close to 0. You think getting close to 0 means getting less, but it doesn't always mean that, depending on where you are. So for the absolute value of x to be less than 2, x has to be greater than negative 2 and less than positive 2. So it has to be in that little group. So another way to write this without having to write two different inequalities is to write x is less than 2 and greater than negative 2. Remember, the open part of the absolute value that looks like an open mouth always goes toward the greater value. Okay, so to graph this, we're going to put an open circle on negative 2 and an open circle on positive 2, because we don't want to include those values because it's x less than 2. The absolute value of x is less than 2, and then we'll include all these numbers between those two values. So it's a little group of numbers, in this case, centered around 0. All right, the next one says graph on the real number line, x, the absolute value of x minus 5 is less than 2. It's the same kind of situation, but now you're talking about x minus 5. You're not talking about x. that x minus 5 can't get any further away from 0 than 2. And so that's a little bit trickier, but if we go back up here and see how we talked about it in this situation, we can talk about it the same exact way. If it's got to be closer to 0 than 2 away, then x minus 5 has to be greater than negative 2, and it has to be less than positive 2. So that quantity right there, whatever it is, has to have a value that's closer to 0 than 2. So now we can solve for x, and we'll get x is greater than 3 and x is less than 7. And the way we would write that as a conjunction is we would write x is less than 7 and greater than 3. And again, we're going to graph it with open circles on the 3 and the 7 because we don't want to include those. And we've got this little group of numbers right here between those two values that will work in this absolute value inequality. And if you're not sure if you did it right, you can always check one of your values. So check 5 and see if that works. If you put 5 into this absolute value inequality, you get the absolute value of 5 minus 5 is less than 2. So the absolute value of 0 is less than 2, which is true. That doesn't guarantee that you got it right, but at least it'll give you some idea that you're in the right area. Okay, a greater than absolute value inequality is going to be actually two sets of numbers shooting away in different directions, or a disjunction. So if you want to graph on the real number line, the absolute value of x plus 2 is greater than or equal to 3, what you're saying is this quantity, x plus 2, has to be further away from 0 than 3, or 3 or further away from 0. And what that means is that x plus 2 is greater than or equal to 3, or x plus 2 is less than or equal to negative 3. Because greater than 3 means it's shooting off to the right, away from 0, 3 and greater. And if x plus 2 is less than or equal to negative 3, it's 3 away from 0 on the left side and shooting to the left to bigger and bigger negative numbers. Okay, so now we can solve for x and figure out what numbers we need to graph. So x is greater than or equal to 1, and here x is less than or equal to negative 5. So this is two different sets because numbers can't be greater than 1 and less than negative 5. There's no number that fits that description. So we are going to have two sets when we have a greater than situation with your absolute value. So we're going to have x greater than or equal to 1, so shooting off in this direction. We're putting a solid dot on 1 because it's greater than or equal to, and then less than or equal to negative 5, so shooting off in this direction. Now, if we graph a function that is an absolute value function, like y equals the absolute value of x, we can see what's happening here. We're going to be putting numbers in for x and y, and no matter what we put in for x, we're always going to get a positive value for y. So we know that this function is never going to go below the x-axis. Y is never going to be negative. So we know we're only dealing with quadrants 1 and 2 for this graph. And we can pick a few values and see what happens. All right, if x is 0, clearly y is 0. If x is 1, y is the absolute value of 1, which is 1. If x is 2, y is the absolute value of 2, which is 2. So when you're on the right side of the y-axis, when you're only putting in positive values for x, this looks exactly like the line y equals x, which is this line. I'm going to find my pen. It has disappeared from me. Where is it? Oh, there we go. Which is this line here. Okay? But when you get to the left side of the y-axis, when you start putting in negative values, well, you get positive values. So the absolute value of negative 1 is positive 1. So negative 1, positive 1. Absolute value of negative 2 is positive 2. So there you go. And now this graph is looking kind of like the mirror image of the one on the right across the y-axis. So this is coming down like a straight line. Well, that's really bad. Sorry about that. But this is what an absolute value function looks like. It looks like a V. It's kind of like a line that got bent up. The line would have gone down here, x equals y goes this way. But since y keeps getting forced to be positive, the line got bent up. So now it's up in the second quadrant where y is positive. Okay, now we're going to look at reciprocal functions. Reciprocal functions are going to have asymptotes, which I talked about a minute ago. These are lines that the function can approach but never touch, because reciprocal functions always have a denominator, and a denominator can never be 0. So for this first function, y equals 1 over x, we know that x cannot be 0. And because x can never be 0, the y-axis is an asymptote. The y-axis is where x is 0. All the points on the y-axis have an x value of 0. So that is an asymptote. We can approach that line, but we'll never be able to touch it or cross it. We also know that y is not going to be 0 because there's nothing you can put in to this function to get y equals 0. No matter what you put in for x, 1 over x will never be 0. So the x-axis is also an asymptote. We can't touch it. We can't go across it. So these two lines are going to be lines that we approach but never touch. So what's going to be happening here? Well, we know that if x is positive, y equals 1 over x is positive. So if we look at some values, as x gets bigger, well, first of all, if x is 1, y is 1. If x is 2, y is 1 over 2. If x is 3, y is 1 over 3, and so on. So the bigger x gets, the smaller and smaller y gets, but it never becomes negative. So it gets closer and closer to 0. Y gets closer and closer to 0 as x gets bigger. So you have this part of the graph. It is approaching that x-axis and getting closer and closer, but it'll never touch it. And then when x is between 0 and 1, what happens? Well, if x is 1/2, then y is the reciprocal of that, which is 2. When x is 1/3, y is the reciprocal of that, or 3. When x is 1 over 100, y is 100. So what's happening in the area between 0 and 1, when x is between 0 and 1, is that as you get closer and closer to the y-axis, tiny little fractions, you're shooting up to bigger and bigger values of y. But you'll never touch that y-axis. So that's part of the function, but we haven't dealt with what happens when x is negative. So we have to look at that. When x is negative 1, when x is negative 1, y is negative 1. So we have negative 1 right here. When x is negative 2, y is negative 1/2. So that is going to, so x is negative 2, y is negative 1/2. When x is negative 3, y is negative 1/3. So as you see, again, it's kind of like what's happening in that first quadrant. Now, as x gets smaller and smaller in becoming more and more negative, we're getting closer and closer to the x-axis. We're getting to these tiny negative fractions. They get closer and closer to 0, but never actually touch that axis. Then, if we talk about the numbers between 0 and negative 1, the same thing is going to happen that happened up in the first quadrant. When you have something like negative 1/2 for x, you're going to get negative 2 for y. And then when you have negative 1/3 for x, you're going to have negative 3 for y. So you're getting closer and closer to that y-axis. And when you have negative 100 for x, negative 1 over 100 for x, you get negative 100 for y. So it's the same kind of thing that's happening. The closer you get to 0, the further and further down you shoot into bigger negative numbers in absolute value. So this is what the reciprocal function 1 over x looks like. 1 over x squared looks a lot like it, except now you won't have anything in the third quadrant. Like in 1 over x, we had, sorry, can't find my pen. In 1 over x, we are in the first and third quadrants. But when we have y equals 1 over x squared, we're never going to go below the x-axis because this can never be negative. X squared is always positive no matter what x is. It's going to look very similar to y equals 1 over x, except it'll be in the first and second quadrants. So in the first quadrant, if we pick values of x that are to the right of the y-axis, positive values, if we pick, well, first of all, remember again, this can never be 0 because x can't be 0 because that will make the denominator 0, and the function y can never be 0 because there's nothing you can plug in for x that will make 1 over x squared 0. So again, we're never going to touch either one of these axes. But so those are our asymptotes. And if we put in something like 1 for x, again, we're going to get 1 over 1 squared, which is 1. If we put in 2 for x, we're going to get 1 over 2 squared for y, which is 1 over 4. So you still have the same kind of thing happening as happened on the other graph, except now it's happening faster. You're getting closer and closer to 0 as x gets bigger and bigger. As the denominator of a fraction gets bigger and bigger, the tinier the fraction becomes, the closer to 0 it gets. Then if you start putting in values between 0 and 1 for x, things like maybe 1/2 for x, you're going to get 1 over 1/4, which is 4. So it's very similar to what was happening in the other function. The closer and closer you get to 0 from the positive side with x, the bigger and bigger the function becomes. X is closer and closer to 0. Tiny little fractions like 1/1000th, those are getting big, big values like 1,000 squared for y. Now, if you start putting in negative values for x, like negative 1, 1 over negative 1 squared is positive 1. So negative 1, positive 1. And if you put in negative 2 for x, you get 1 over 4, so positive again. And again, what's happening is as x becomes more and more negative, this function gets closer and closer to 0. That denominator keeps getting bigger and bigger, which makes the fraction tinier and tinier, closer and closer to 0. And then if you're between 0 and negative 1 on this function, you're getting things like if we put in 1/2 for x, negative 1/2, sorry, we are getting 1 over positive 1/4, which is positive 4. So we're up here. And again, same thing's going to happen. As x gets closer and closer to 0, some tiny little fraction of a negative fraction, it's going to shoot up to bigger and bigger values of y because you're going to flip it upside down and it will become big. So that's what that function looks like.